Hello friends, so we have a question on application of derivatives. The population P of a particular species on a small remote island is given as a function of P, K and N. And we are given that dP by dt is equals to this. Now, in the context of the model, we have to interpret the meaning of dP by dt. So what does dP by dt means? dP by dt basically means the rate of growth of the population of this particular species with respect to time, the rate of growth, dP by dt. Now in the B part, we have to identify d square P by dt square. So we are given dP by dt as K into P into 1 minus P by N. So we have to basically differentiate this term with respect to time. So this is dP by dt is to be differentiated with respect to time. So what do we have to do is we have to differentiate this whole term Kp into 1 minus P by N with respect to time. So here we get is d square P by dt square, and on the right side we will be differentiating this with respect to time. So what we get is derivative of this Kp minus Kp square by N with P multiplied by dP by dt. So what we get is K into derivative of P with B is 1 into dP by dt minus 2 times Kp by N into dP by dt. Now we can take K into dP by dt as common. We will be left is 1 minus 2P by N. And dP by dt can be replaced from our original equation. So this will be K square P into 1 minus P by N into 1 minus 2P by N. So this is your solution of B part. In the B part, we have to prove d square P by dt square equals to K square multiplied by P multiplied by 1 minus P by N multiplied by 1 minus 2P by N. Now in the C part, we have to show that the population will increase at its maximum rate when P is equals to N by 2. So this rate will be maximum at P equals to N by 2. So we have already differentiated this once. So what we have to do is we have to show that at P equals to N by 2, this dP by dt has maxima, so that its first derivative will be changing its sign from positive to negative. So let us see the first derivative of dP by dt is K square P. I am manipulating this term a little bit. So what I will be doing is P minus N by N multiplied by 2 into P minus N by 2 by N. So you can see this term, this is 0, this is N by 2 and this is N. So here it will be positive, here it will be negative, here it will be positive, here it will be negative. So at N by 2 you can see the sign is changing from positive to negative. That means this is the point of maxima, or you can further check it by further differentiating it and then doing it less than 0. So at P equals to N by 2, the dP by dt is maximum. Now in the D part, we have to determine the maximum value of dp by dt. So we will put p equals to n by t in our expression. Dp by dt is equals to k into p into 1 minus p by n, and putting k equals to n by 2, p equals to n by 2, we get n by 2 multiplied by 1 minus n by 2 into n. So this is k into n by 2, 1 minus 1 by 2. So this is k into n by 4. So this is the maximum rate of growth occurring at p equals to n by. On to the E part. In the E part, we have been asked to solve this differential equation and prove this will be coming of this like this format, and then after using this particular formula we have to find the value of k. So the differential equation in our case is dp by dt is equals to k into p into 1 minus p by n. You can simplify this as k into p into n minus p divided by n. So you can separate the terms of p. This will be n divided by p into n minus p into dp equals to k dt. Now you can integrate this to solve this differential equation. This is basically can be separated using the partial fractions. We can assume it to be a divided by p plus b divided by n minus p, and when equating and solving this you will get a equals to 1 and b equals to 1. So this will be 1 by p plus 1 by n minus p into dp, the integration of this and the integration of k dt. Now the integration of dp by p will be natural log of p, and this will be with the negative sign, natural log of n minus p equals to k into t into some constant c. We have assumed it to be some positive constant c. Now let us try to find the value of c. We know at t equals to 0, p is equals to p naught. So natural log of p naught minus natural log of n minus p naught is equals to t equals to 0. So the value of c will be coming out to be this. So now the value of c has been identified. So we can write this as natural log of p minus natural log of n minus p minus, taking c to the left, natural log of p naught minus natural log of n minus p naught equals to k into t. So you can write this as p by n minus p minus natural log of p naught by n minus p naught equals to k into t. So this is further solved as p divided by n minus p divided by p naught divided by n minus p naught equals to k into t. So this can be simplified as p into n minus p naught divided by n minus p into p naught equals to k into t. This is what was needed to be proved in the E part. Now using this formula we have to calculate the value of k. We are given that at t equals to 10 years, the population is 3 times p naught and the value of n is 4 p naught. So, we will put these values in the formula. P will be equals to 3 p naught multiplied by n, which is 4 p naught minus p naught, divide by n is 4 p naught and the p is 3 p naught multiplied by p naught equals to k into 10. Now we can solve this. This is natural log of 3. P naught will be cancelled, multiplied by 3, divide by 1 into 1 equals to k into 10. So this will coming out to be k into 10 equals to natural log of 9. Or you can further solve k as natural log of 9 by 10. The values can be identified using the calculator. This will be 0.220. So this is the value of k. And for more such questions, do visit our website www.iitnacademy.com and register for detailed explanations and solutions. Thank you.